So in this case, we are going to consider finding the equation of a cubic function. This is a major aspect in our revisions as we are to consider a cubic function. In our previous class, we managed to sketch a cubic function, all right? If you're given f of x, which is equal to, all right, you're given your f of x equal to ax cubed plus bx squared plus cx plus d. We managed to sketch the cubic function. But in our case, we are given that cubic function or some properties of the cubic function. And from those properties, we are to find the equation. We are to find the equation. So this is the major aspect that you have. Remember that the cubic function, there were so many concepts that we had. We had a consideration where we have got two turning points, all right? Where we have got two turning points or two stationary points, all right? A turning point here and a turning point. We had a consideration where we can have a cubic function, which can be something like this, all right? Where we have the x-intercept still having two turning points, but the x-intercept is a turning point as well. The x-intercept is a turning point. Remember, we also had a condition where we have got the stationary point of what? Of inflection, where in that case of a stationary point of inflection, it's either it's either we are considering maximum or minimum. We do not have the maximum or minimum turning points. This condition of the turning points. This is the condition where you are working with what? The stationary point of what? Inflection. So those properties, they can also help us in finding the equation of a cubic function. So I'm going to consider in that manner. All right. So like I said, our cubic function is in the form ax cubed plus bx squared plus cx plus d. So this is the format that we are referring to. So the first condition I'm going to consider, if the x-intercepts, all right, we can have this condition, all right, like this. So it will be maybe x-intercept, 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 three of them from this condition. Considering the x-intercepts, you can have three of them. So given x-intercepts, and there is a turning point or in that function that you're given, here I'm not referring to a condition that you must always be given the turning point. No, they can give us any other point. But what is important is that you have what? The x-intercepts, three of them. So let's consider that if, all right, so if the x-intercepts, are given as x1, x2, and x3, for this condition, we can determine our equation. Let's say we've got something like this. This is our x1, this is our x2, and this is our x3. It follows that y can be written as a into x minus, you subtract the x-intercepts, the x-values, the x-intercepts, the solution. So it's x minus the first one, x1 into x minus x2 into x minus x3. You subtract the x-intercepts. So this will form an equation of a cubic function in this format. So to find the value of A, you must be given any point on the graph, any point. It can be the turning point, as long it's a point which lies on what? On the given cubic function. Thus, you use that to determine what? The value of A. So to find the value of what? The value of A, the value of A, use any point which lies on what? Use any point which lies on the cubic function. On the cubic function or the cubic graph besides what? The x-intercepts, all right? Besides the x-intercepts. Do not use what? The x-intercepts. You use any other point besides what? X-intercept. So that is it. That is the condition. Simply substitute any point on the graph besides what? The given constants, besides the given roots of that graph, all right? So the equation at the end is going to be in that format. Like I said, you have to expand the brackets. After that, simplify further, all right? So that is what you're going to need in this case, all right? So that is the condition to find the value of A. And after finding A, expand the brackets and what? Simplify. So after expand the brackets and what? Simplify. And simplify. So that is the major condition that you're going to have. Then the second part is when you are given one of the x-intercepts like this as a turning point, all right? So that can be a condition to consider if one of the x-intercepts is one of the x-intercepts is a stationary point or is a what? Is a turning point. When the x-intercept is given, all right, of a certain cubic function, and that x-intercept is a what? Is a turning point. We can have a condition like this, all right? And we have got what? X-intercept as a turning point. This is the condition that I'm referring to. If this occurs or if this happens, that one of the points is a turning point, the format is still the same, but you have to be careful where you have a turning point. You treat this part as we have got two solutions here, two values of x. So it's actually this at the turning point. There are what? Two solutions of x. It is like x is equal to x2 or x is equal to x2 as a repetition. That is what actually happened. So when you have in your equation, it is going to be a into this one. Just take it as it is, x minus x1. But where there is a turning point, where we've got two solutions at that point, you must square the bracket. So it's x minus x2 squared. Because there are two solutions there. So you square that bracket. So just like what we had before, you must have another point in order for you to find the value of A. You use any point besides what? The x-intercepts. Expand the brackets and what? Simplify. that is the same condition that you're going to have as before. All right. Another consideration that you're going to have is when a cubic function has got a stationary point of inflection. All right. So if a cubic, let us consider this, if a cubic function has a stationary point, so let's say it has a stationary point of what? Of inflection. Remember, this is a condition where you do not have the maximum or minimum turning point. All right, you do not have the maximum or minimum turning points. Let's say just something like this, it curves back. And there is a point of inflection. At that point, it is actually representing the same as a turning point for that point of inflection. It is also a turning point in actual sense. All right? So that is the condition. Let me just try to redraw this properly so that you can see this, something like this. Just like this, all right? So at that point, it is neither maximum nor minimum. So let's say we have that point as negative PQ, right? It's only that the side where I took this, it might not make sense. Let me just shift it like this. All right. Sorry for that. So I'm just going to do it like this. Okay. So let's say we've got this point as negative PQ. This is just a format of representing the point. So negative PQ is our stationary point of what? Inflection. This one. All right, that's our stationary what? Stationary point of inflection. For this case, to obtain the equation of our cubic function, it follows that y is equal to a into x plus p. It was a negative. The moment you substitute here, it will be positive p to the exponent of 3. Then the q, you just rewrite as it is. All right? So x, the x value changes the sign. The y value representing q remains as it is. So this is what you're going to need. To find the value of a, you're going to need another point on the graph besides the stationary point of what? Inflection. Then you can expand your brackets if you are told to do so. Sometimes they will just give you a question, then write your answer in this form. So you simply have to leave your answer in this format as it is, all right? So that is some of the conditions which are basic in our revision or when we are dealing with what? A cubic function. These are some of the basic formats that you must actually understand because they repeat these conditions now and again. So questions can be like this. Determine the equation of each of the following cubic functions in this form. All right, we are given the first part, A. If you are to look into the sketch that we are given here, we have the x-intercepts of our cubic function, and there are 3 of them. 1, 2, 3. So this will be our x1, our x2, our x3. So when we are given the 3 x-intercepts, the 3 roots of our cubic function, simply write in that format, all right? So that's for our a. Y is going to be equal to a into x minus x1 x minus x2 into x minus x3, where these are the x-intercepts. -1, so that's a into x minus our x1 is a negative. So negative will give us what? A positive. All right, x minus x2, the second root, our x2 is what? Is 2. So that's x minus 2 into x minus our x3. The third root is what? Is 3. So this is what you have. And like I said, from that, you can determine or find the value of A. All right? To find the value of A, use any point which lies on the cubic graph besides what? The x-intercepts, besides the root. Any point. Is there a point on our f of x on this function? Yes. There's a point 112. So that's the given point that you're going to use besides these ones. There's a point. You've got the x value, the y value. Substitute that point, all right, to obtain what? To find A. So that is to find what? To find the value of A. To find the value of A. We are going to use any point. So use 112, the point that is what? Given, which represents our x and y. So x is 1, y is 12. So y is what? Is 12. When our x is what? When our x is 1. So in place of x, you're going to put a 1, to put a 1, to put a 1. So what are you going to have? 1 plus 1, that's a 2, times 1 minus 2, that's minus 1, times 1 minus 3, that's minus 2. So expand this. Expand the right-hand side. Multiply on your calculator. That is going to be 2 times -1 times -2. All right, which is going to give us what? A positive 4. So that is a positive 4. 4 times what? 4 times A, which is 4A. So to find the value of A, since we have a product, simply divide by what? Simply divide by 4. So A is equal to 12 divided by 4, which is what? Which is 3. So meaning to say from this equation, it follows that y is equal to, in place of A, substitute the 3. So that is 3, all right, into what? The given brackets, x plus 1, x minus 2, x minus what? X minus 3. So this is where you are. And what you need is to expand brackets and simplify to have our answer in the format y is equal to what? This. So let us expand our brackets and what? Simplify. So expand brackets and what? Simplify. So let us start with these two brackets, all right? So it was going to be y is equal to 3 into x plus 1 into what? So what are you going to obtain? This you can just have it aside, guys. The bracket of x minus 2 and that of x minus 3. It's going to be x times x, which is x squared, times -3, -3x, -2x, -2 and 3. That's going to be positive 6. Collecting the like terms here, -2 and -3 is going to give us -5x plus what? 6. So this is what you are going to have from the expansion of these two brackets. You're going to have x squared minus 5x plus what? Plus 6. All right, so this is it. Then we have another bracket to consider, the bracket of what? X plus 1. So this x plus 1 is supposed to multiply everything here. All right, so let us just expand it on this one. So it's going to be 3 into x is going to multiply everything in the second bracket. All right, so that is the consideration. X here multiplies x squared. That is going to be x to the exponent of 3. All right, times 5x. That is going to be minus 5x squared. X is going to multiply 6 here. So it's going to be what? Positive 6x. We are done with x. We move on to positive 1. It multiplies x squared. 1 times x squared. That's x squared. All right, 1 times 5x minus 5x, that's minus 5x. Then 1 is going to multiply positive 6. That is what? A positive 6 that you're going to have. And simplifying this, collecting the like terms, is going to be 3 into x cubed. There are like terms, the terms in what? In x squared. There is this x squared. So consider minus 5. There is here x squared. What is the coefficient of our x squared? That is what? 1. So you subtract minus 5 plus 1, which is what? Negative 4. So it was going to be minus 4x squared. We also have like terms here in x. So this is positive 6. This is what? Negative 5. So you're going to subtract 6 minus 5, that is 1x. So 1x, guys, is same as what? A positive x plus what? Plus 6. So this is it. From this expression, you can expand throughout by what? By 3. Each and every term in this bracket multiply by 3. So 3 times 1, that's 3x cubed. Here there is a 1, the coefficient of what? Of x cubed. So it's going to be 3x cubed. 3 times negative 4, that's negative 12x squared. 3 times 1, the coefficient of x is 1. So 3 times 1, that's going to be positive 3x. 3 times 6, that is going to give us what? 18. All right. So that is the equation of our cubic function from what we had. All right. So you must consider what you are given in this case. Then write it in the format, the form that you're given there, which is from expansion of what? Expansion of brackets, then simplifying, just like that. All right. So considering the second part of our question here, we are going to see that it is simply one and the same, only that there is the x-intercept, which is also a turning point. That is the consideration that you're now having on B. If you're to consider this, the x-intercept in the x-axis minus 2 here is the x-intercept. It is also what? A turning point, while it's an intercept. So when this occurs that one of the given points is a turning point, one of the x-intercepts is a turning point, you square that part where the turning point is. You must what? Square that part when you consider your f of x. So in our case, it was going to be y is equal to a into x. All right, let's say this is our x1, this is our x2. So x1, you are going to subtract this, then square. That's where we have a turning point. So it's going to be x minus x1 squared. All right, into x minus x2. You are not going to square this one because there's a what? A single, so just a single solution. Here there are two solutions where there's a turning point. So you square that part. And there is a point given, negative 3, 4. So for the value of x and the value of y to find the value of a. You are done. So that's it, guys. As you can see, it's just a repetition. So that's x minus 2. So minus is going to be what? A positive 2. All right. Into x minus, our x2 is positive 1. So it's going to be just x minus 1. So let us find the value of a from the point minus 3, 4. You are going to find what? The value of a, where x is what? 4. All right. Our x is what? Our x is negative 3. So you put negative 3 here, negative 3 here. So you can just even square as it is on your calculator, or negative, right? Like this, you can just even just square it. Negative 3 plus what? Plus 2 squared is going to give us a positive 1. All right. This is negative 3 minus 1 is going to give us negative 4. So this is it. So to find the value of a, we can simply multiply this 1 times negative 4, that's negative 4a. So divide by negative 4. to find the value of A, which is going to give us what? -1. 4 divided by what? -4. That's a -1. With the value of A, substitute it back in the given equation so that you can find Y there in terms of X. So remember, Y is equal to this, where A is -1. So that's -1 into X plus 2 squared into X minus 1 like this, of which guys -1, you can just even ignore this and just write a negative. So this is where you are. You need to expand brackets and what? And simplify. So this is the same as Y is equal to minus. You take this linear bracket of X minus 1, square the X plus 2, this one. This is X plus 2 what? Squared. Simplify that on its own. All right. So you're going to obtain what? If you simplify that X plus 2 squared. Remember, you can also use that expansion when you square a binomial, or you can simply expand 2 brackets of X plus 2. All right, 2 brackets of what? Of X plus 2, like this. Or you can simply use A plus B squared, which gives us what? A squared plus 2AB plus B squared. So this is going to be X squared 2ab, that's 2 times x times 2, which is what? 4x. B squared, 2 squared is what? Is 4. Or simply expand the brackets as usual. This is what you're going to have. And just like before, expand the brackets. Y is equal to negative. As we can see, this bracket and this bracket, x is going to multiply everything in the second bracket. So x and x squared, that's x cubed. X multiplies, all right, x here multiplies 4x. That's going to be positive 4x squared. So you multiply each and every part, all right? Sorry for that. So this is 4x squared, all right? 4x squared like this. And x is going to multiply 4, and that is going to be positive 4x. So we are done with x. We move on to -1, multiplying x squared, that's minus x squared. -1, multiplying 4x, that's -4x. Then -1, multiplying 4, that is going to be what? A -4. So at the end, y is equal to, let us just try to simplify by collecting like terms in within the bracket. We have got 4x squared minus x squared. This is simply 1x squared. So 4 minus 1 was going to give us what? A 3. So that's 3x squared. We also have the like terms here, the 4x and the 4x. So that was 4 minus 4, which is a 0 there. So this was going to actually cancel. Then you remain with what? A negative for the constant. So this is it. This is what you have, and expanding by the negative, this is -1, remember? So simply multiply each and every term by the negative outside of the bracket. So negative and x cubed, that's negative x cubed, negative and 3, that's -3x squared. Negative is going to give us what? A positive 4 at the end. So we have our expression, we have our equation actually of the given cubic function in expanded format. So we can even leave our answer like this, all right? So you have to consider properly, guys, what you are given. What you are given in terms of the sketch. There we had an x-intercept, which is also a turning point. So that point, when you substitute that solution there, you must square it. X minus this squared, all right? So that is how typically these questions can be given as, all right? Another one, you are given here to determine the equation of the following cubic function in this format. where you do not have this condition of a turning point properly given. This is what? The stationary point of inflection that we are given here. This is the condition, the stationary point. The stationary point of what? Inflection. So with this, remember our format here. If we are given f of x, all right, if you're given this f of x, y is going to be written in this form. From the point minus pq. So in our case, if it was given as minus pq like this, we know that we're going to substitute as y is equal to x into what? X plus p cubed plus what? Q, like this. So take note, that's a into x plus. It was a negative. When substituted, becomes a positive. So a negative 1, this one, when you put it back, is going to be a positive. It changes this one. So it will be what? Positive 1 to the exponent of 3. Q is not affected, this Q. It's still the same. So that is the Y value is not affected. So minus 2 is not affected. It remains as it is as a what? As a negative 2. That is the condition. But we need to determine or to find what? The value of A. Just like what we had before, to determine that value of A, we need any point which lies on what? On the graph. Besides what? The stationary point of inflection that we used here, besides that, is there any other point? Yes, there is a point, negative 3, which is in the what? In the y-axis. So we have got what? The y-intercept here, which is what? X is equal to 0, y is minus 3. So we can use the point 0 minus 3 to find what? Find A. That's it. When y is what? Minus 3. At that point, x is what? X is 0. So it was going to be 0 plus 1 to the exponent of 3, which is what? Which is 1. All right? Minus what? Minus 2. So let us solve for A. This is a linear equation. Take the minus 2 to the other side. It's going to be a positive, or simply add 2 both sides of your equation. So A times 1, that's A, minus 3 plus 2, that is going to give us what? A negative 1. Remember, you are adding 2. So this is the value of A that we have obtained. Substitute it back in here. So therefore, y is equal to what? Our A is negative 1. So that's negative into x plus 1 to the exponent of 3 minus 2. Remember, in this format, do not expand. The format here is not expanded. They want you to leave your answer in this format. Y is equal to A into x plus what? X plus p cubed plus q. So do not expand. According to this format that you're given, to leave your answer as, do not expand. You can only expand if they say in the form ax cubed plus bx squared plus cx plus d. This one, you must expand the brackets in order for you to have your answer in this format. All right? So these are the typical questions, as we can see. All right? Another question that you're given, which is a basic example that we are going to use. Like I said, it is not always when it is a direct approach to the question. Sometimes they just need you to play around the information. They were given a sketch. All right? The sketch alongside shows the graph of f of x. And our f of x is given as what? Ax cubed plus bx squared minus 12x. Minus 220 is a stationary point of what? Of f. It is what? A turning point. So determine the values of A and B from that. Still, we are to determine what? The equation by finding A and B. But in this case, we do not have anything on these roots or the solutions or the x-intercepts. So what is it that we can use? Remember, they gave us a turning point. So let us go back to our derivatives. What is that you understand about the turning point? We do understand that at the turning point, the first derivative of the given function must be equal to what? To 0. This alone is an equation. This, because we're saying this is equal to this. So we can form an equation from our f of x using this derivative concept. Using what? The derivative concept. So let us determine the first derivative with respect to x. Remember, I dealt with these derivatives with constants. Just treat a constant as any other number, right? So with respect to x, multiply by 3, subtract 1. So 3 times a, that's 3a, x to the exponent of 3 minus 1, which is 2. Here you multiply by 2, so 2 times b, that is going to be 2b, x to the exponent of 2 minus 1, which is what? Which is 1. So just leave it as 2bx. Minus 12x, this is a linear term. So in differentiating, we're just going to take the constant, which is what? Minus 12. So we're saying that this is our first derivative. But this first derivative is what? Equal to 0 at the turning point, at our turning point at minus what? At minus 220, where x is minus 2. The first derivative is equal to 0. So you can put that into consideration now to say, since the first derivative is supposed to be equal to 0 at this point where x is minus 2, let us take our first derivative, 3a. Our x is what? Minus 2 at the turning point. So this is going to be minus 2 squared. All right? Plus 2b. The value of x is what at the turning point? It is negative 2. All right? Minus 12. If we substitute the value of x here at the turning point into this first derivative, guys, we must obtain a 0. As long we are dealing with a turning point, you must obtain what? A 0. So thus, an equation formed. Simplify this as we've got C, I've got 2 unknown values, so you cannot solve for A or B because we've got 2 unknown values. But let us just simplify. The constant here, 3 times what? 3 times negative 2 squared is going to give us 12. So that's 12 times what? 12 times A, which is 12A. 2 times negative 2, that's negative 4b, minus 12 is equal to 0, all right? I can leave it like this. I can take the minus 12 to the other side and also try to reduce this equation. So it's going to be positive 12. Remember your simultaneous equations. When you've got 2 unknown values like this, you can as well reduce this equation by the highest common factor between these numbers, which is what? Which is actually 4. So reduce by 4, by 4, by 4. That's going to be 3a minus 4 and 4. That's a b. 12 divided by 4, that's a 3. All right? We cannot solve for a or b, so let us just leave this as our equation 1. We formed an equation from the turning point concept that the first derivative must be equal to 0 at the what? At the turning point. Since we cannot solve this equation, like we cannot solve for A, we cannot solve for B because we've got what? 2 unknown values. form another equation. So you are supposed to what? To form another equation from any idea that you understand about the function. All right, we applied the turning point. That's the only special point on our graph. So what is that we can use again, guys? Are we seeing that the same turning point here? Yes, it is a special point to say it is a turning point. But as well, this turning point is just a normal point on what? On f of x. That turning point that we are given, negative 220, remember that. It lies on what? It lies on the graph, on our f of x. So if it lies on the graph, it means from our f of x, right? It lies on what? It lies, guys, what am I writing here? It lies on the graph, which means lies on what? On f of x. So it means for the x value, when it is minus 2, this x value, when it is what? A negative 2, y is equal to what? 20. So simply substitute into f of x. From f of x, remember your f of x is given as ax cubed plus bx squared minus 12x. Substituting x here, which is negative 2, in place of x putting negative, put negative 2. And y is what? Is 20, your f of x. It follows that 20 is equal to, all right, this is going to be a into what? Our x, negative 2. So that's negative 2 to the exponent of 3. All right, plus b, our x is what? Our x is negative 2, remember? So that's negative 2 squared. Minus 12 times x. Our x is what? Negative 2. So this is what you were actually going to have at the end. All right, then try to simplify just like before. So it's going to be 20 is equal to negative 2 to the exponent of 3. That's negative 8 times a. Negative 2 squared, that's 4 times b, which is 4b. Negative 12 and negative 2, that's positive what? 24. So you can also try to simplify in simplest form just like this. All right, so what we can do here is we can just take this to the other side. It's not a problem. So it will be 8a minus 4b. The b is going to be negative. Negative 4b is equal to 20 to the other side is going to be a negative 20 here. So it's simply 24 minus 20, which is what? 4. And I can even reduce it by the highest common factor of these numbers, which is going to be what? 4. So reduce by 4 by 4. That will be what? 2a minus b is equal to 1. So we have the second equation from the point t, from what? The point minus 220, which is our turning point. It lies on the graph on our f of x. Besides that, it's a turning point. Its property, again, is that it is a point found on what? On f of x. So it must maintain those properties to say that if you are to consider this part, if you are to consider to say it lies on the graph, for the value of x when it is minus 2, y is supposed to be equal to 20. So this is it. For the turning point, it is the condition of the first derivative to be equal to 0 at the value of x, which is at this point condition where x is what? Minus 2. But the first derivative is what? Equal to 0. So do not confuse between the two. So you have formed two equations here. You can find the value of a and the value of what? Of B. All right, so 3A minus B is equal to 3. That's our equation 1. Our equation 2, 2A minus B is equal to 1. Using any method to solve simultaneous equations. All right, in this case, since these two are the same, I can easily eliminate, all right? I can easily eliminate B using elimination method. Since these two are the same, I must subtract to eliminate that. So 3A minus 2A, that's A, all right, is equal to 3 minus 1, which is 2. So A is equal to what? A is equal to 2. When A is equal to 2, find the value of B. Simply substitute 2 in place of what? In place of A in any of the equations. So I'm just going to use the first equation. All right, in place of A, I'm going to put what? 2 minus B, that's equal to 3. 3 times 2, that's 6, minus B is equal to 3. So I need to solve for what? For B. Minus B is equal to what? Taking the 6 to the other side is going to be a negative there. So 3 minus 6, that's a negative what? A negative 3. All right, so to find the value of B, simply divide by what? Simply divide by a negative. So B is equal to what? A positive 3. All right. So this is the condition as to have what? The value of A and B from our f of x. This was the condition, guys. We have a stationary point, a turning point. So the derivative of the function must be equal to 0. But that point as well lies on the graph on f of x. So use it as a normal point by substituting the value of x to give us the value of y, which is what? Which is 20. Form two equations in A and what? B, two simultaneous equations, then solve using any method that you understand. You've got your A and what? Your A and B. So that is how these questions basically can be given as. Another one, it is to sketch, all right? The sketch alongside shows the graph of what? Gx, this sketch that we have. Determine the values of P, Q, and R, all right? Our Gx is given as x cubed plus px squared plus qx plus r. So the coefficient of x cubed, it means is already what? A 1 when it is like this. So we need to find P, Q, R. Where R there, you can simply tell, guys, when x is equal to 0, the y-intercept, y is what? Negative 3. So you can tell that R is equal to negative 3. That's what? The y-intercept, where x is equal to what? 0. But was this going to help us to find the P and Q? We are limited from this. All right? We are limited. But let us see, there is this part, which is our x-intercept. All right? Which is, we have got an x-intercept 3. There, we have the value of x here. But what is that we know is that it is supposed to be a turning point. It is supposed to be a solution as well. This one is a solution. It's a solution. All right. So what can we do, guys? All right. So here we are limited with a lot of things. All right. Let me just take the easier way. The easiest way is to form the equation as if you were given this x value. How are you going to determine the equation? Remember, our gx is going to be equal to a into x minus x1 squared into x minus x2, because we have got this root at the what? At the turning point, we must square it. But in our case, we do not know that, all right? We do not know it. But because we know the value of a, that a is equal to 1, And x2 is what? This one, we know that it is 3. So it will be like you are just having one unknown value. So it will be easier for you to find that value of x1 and expand so that you can have your equation in this form. So it will be easier that way. All right? So what I'm trying to say is that we're going to have gx is equal to a into x minus x1. We do not know our x1, so just leave it like that. All right? Into x minus our x2 is what? Is 3. That is what? A 3. So this is what I'm trying to say, guys. Since we know that our a is what? All right? There was no need here of rewriting this a here because we know that a is what? 1. The coefficient of x cubed is what? Is 1. So if you are to consider here, we can find the value of x1. So what we need is to find what? X1. But in order for you to use or to make, in order for you to find this x1, you are going to need any point on the graph besides the roots. Use any what? Any point besides the x-intercepts. There is a point given here, the y-intercept. It's not the x-intercept, it's the y-intercept. So use that. We are given the point what? 0, minus 3. So using that point 0, minus 3, we have got the x value, the y value. So substituting y is what? Minus 3. So minus 3 is equal to, all right, our x is what? 0. So that was going to be 0 minus 1 minus x1. 0 minus x1 squared. 0 minus x1, it's minus x1. Then we square it. A negative squared becomes what? A positive. So it was going to be x1 squared. All right? When x is equal to 0 here, 0 minus 3, that is what? That is minus 3. So we need to find x1, remember. So to find x1, divide by the bracket of what? Negative 3. So this is going to cancel, and x1 squared is equal to what? Negative 3 is going to give us what? A positive 1 if we divide. All right, so that is going to give us a positive 1. To find the value of x, introduce the square root. So x1 is going to be what? The square root of 1. We do understand, yes, it's plus or minus 1. But the x in our case is what? According to where our x is, it's on the left side of the y-axis. This is our y-axis. So x1 is on the negative. It's on the negative. It cannot be a positive, all right? So our x1 is what? A negative value, which is what? Negative 1. This value of x1 was the one that was missing here, guys. In order for us to expand, this was the missing what? Value. So you're going to take back the gx that you had, say the gx is therefore or can therefore be written as, remember our a is what? 1. So just ignore that one. So it's going to be x minus x1. Remember our x1 is negative 1. So minus is going to be a positive. X minus 1 squared into what? X minus 3. So you substitute the value of x1 in place of x1. That bracket was going to be a positive. So how can we determine those values of P and Q? If you check, this is in expanded form. It's in what? Expanded form. So simply expand the brackets, write them in that format. We are done. You can tell what is the value of P, what is the value of what? Of Q. All right, so let us expand x plus 1 squared from our expansion. Guys, you must know this is going to give us x squared plus 2x plus 1, or just properly expand 2 brackets, x plus 1, another bracket, x plus 1. You're going to obtain this, all right? Then expanding by x, the second bracket, x and x squared, x cubed, and 2x, 2x squared, x and 1, that's positive x. Then minus 3 multiplies the second bracket, so it's negative 3 times x squared minus 3x squared times 2, negative 6x, negative 3 times 1, negative 3. Then collecting the like terms, you're going to find out that our gx is x to the exponent of 3. Then here we have got 2x squared minus what? 3x squared. So the terms in what? In x squared on their own. So that was 2 minus 3, which is negative 1. So that's negative x squared. We consider x here and what? Minus 6x. These are like terms as well. So this is 1 minus 6, which is what? Negative 5x minus 3. All right? From this, that's where we can tell what represents P, what represents Q from the format. Remember the format here. Remember our format. So rewriting that format here, rewriting our format of gx, which is x cubed plus px squared plus qx plus r. We can tell what is our p, the coefficient of what? X squared, which is what? Negative 1. So therefore, p is equal to negative 1. Q, the coefficient of what? Of x. What is the coefficient of x there? Negative 5. So therefore, Q is equal to negative 5. And our R is the constant. It is what? A negative 3, which is the same value of R that we determined here from what? From the graph to say it is the y-intercept at what? At negative 3. So you see, guys, it must tally. It must be the same thing. So expansion of brackets was actually necessary for this format, and here it was important to find the x value. Since we have our a, the a is given, so we are just left with x1 as our unknown in that equation. So you can find it. After finding, substitute back into that format, expand the brackets, simplify to have your answer in this expanded format where you can tell what represents P according to what? The coefficient of a certain variable or certain term. So that is the condition. So it's all about revision, guys. Please do revise, understand all the basics, all right? All the basics from the properties here of just obtaining the equation of a cubic function from the type of a cubic function and adding some other properties from our derivatives, such as the idea of the turning points, knowing that at any turning point, the first derivative is equal to what? Is equal to 0. So that can play a role in determining values of what? A, B, C, and D, or in finding the equation of what? Of a cubic function. So those are the basics. Let us do revise. We are going to add more questions as time goes on, but for now, that is it till we meet again.